Hi, this is a continuation of our class from Royal Society to Breakthrough Prizes and a Nobel Pursuit. So in this session, we'll primarily focus on Nobel Prizes history, covering the major scientific fields. I will, as mentioned earlier, I'll avoid the peace and the economics prizes because that's not pertaining to the science. Uh, and now, when it comes to science, there is always a statement by well-known physicists that there is unreasonable effectiveness of mathematics. Similarly, when it comes to scientific recognition in any fields, there is an unusual, there is an unreasonable prominence to Nobel Prizes. And why that is hard to fathom, especially considering that it is a sort of outdated way of recognizing the prize work. And the people who won the awards are already recognized in their field as leaders. Now, like I think it's George Bernard Shaw or Mark Twain, somebody said it's like handing a life jacket to somebody who is already near the shore, so to speak. I mean, let's take, for example, Albert Einstein was already well known, and famous uh, by the time he was recognized by the Nobel Committee. In the same way, the most recent winner, Jennifer Doudna, was already a leader in her fields. People were seeking her out for postdoc positions, and when it obviously in the old days, the financial reward was substantial, but now even that has fallen by the wayside because a lot of them have funded companies and are richer, you know. Okay, so but still there is a prestige, especially since due to the Royal Association and the pomp and circumstances. Perhaps the same way we are fascinated by the British royalty, and the Swedes have done a remarkable job in marketing this. So it's still a tradition that continues, and every October, people look forward to who is going to be get the nod or the phone, the proverbial phone call. And even now, even amongst the young graduates, there is fascination. If you ask Caltech postgraduates, what is their biggest dream, so to speak, is to go to Stockholm to get the Nobel Prize. Okay, and this is probably a day when the scientists can take off their white lab coats and pocket protectors and put on tails and long frock coats, travel to Sweden in the cold weather and guzzle champagne with culture in the age of progress. Now, this is again, this is affected by the lot of politics that goes behind uh, the scene, so to speak. And there is a big national pride that is involved. In the old days, there was a rivalry between Europeans and Americans. And obviously, there are a lot of oversights, and the Asians have always felt that they've been ignored. Women have been ignored most of the times, but I think now they're trying to make this up with a vengeance that women seem to be dominating. Okay, and and after winning, and also there is a rivalry even in the United States alone is between the East Coast and West Coast per se. Okay, so enough digresses. Let's put the year 1900 in perspective. What was going on in the other fields? For example, Sigmund Freud was really a true neurologist, and just getting into his psychoanalytic pseudoscience frame. And at the same time, in archaeology, Arthur Evans had done excavation that we talked about in the other class. Hugo de Vries was rediscovering Mendel. Max Planck, who was a well-endowed, well uh, trained physicist, he was told that everything that has to be discovered by has already been discovered, so there is not a whole lot to be left. And it just goes to show as to how wrong they turned out to be, because a lot of things were already around. Remember, I think automobiles were around. Early Wright brothers had already making their attempts to fly. The balloons were around. A lot of the mysteries of science, such as electricity, magnetism, gases, thermodynamics, optics were already being worked out. And even so this was in the lot of the fundamental laws of science, not just Newtonian, but the other electricity laws, such as Ampere law and Ohm's law, and all that were already worked out. So people thought, okay, well, we can put a finish label on it and get on with our lives. At the same time, on the cultural front, Pablo Picasso was making his forays into Paris, and this is his famous painting called Science and Charity that he depicts, a contemplative mode. Okay, so that's just sets a perspective. Now, who was Alfred Nobel? He was came in from a rich family. His parents had weapons factory in Tsarist Russia, and that was and by the time he trained in Paris and was making his own discoveries and inventions. And this they were already a big military industrial complex, way before. Now he made his own discoveries because nitroglycerin was discovered by various Italian chemists at that time, but it was highly explosive. And there was a way to, if we're going to effectively use it, there had to be a way to effectively control the explosion. And so he discovered varieties of ways by slowing down the explosive potential by putting in a type of a soil that came from somewhere in Germany called Kesselgor, and discovered the cap for the gunpowder and managed to make effective use, and then uh, again, so varieties of a type of a special type of soil that he was able to use. And again, and there he had varieties of patents. He had factories all over the world making gunpowder, smokeless gunpowder, explosive for mining industry was coming into the foray. So he was his inventions were widely effective. And still, one of his companies, is still very much around and in business. And you can see how from the bottom diagram here as to how widespread they're in is not just in mining, but in quarries, metal mining, and various construction areas. So it was very much, for the forefront of industrial empire. Okay, and now, what prompted him to get into this award and science business? Okay, it was a mysterious story that one of his brothers, he came from a large family, as they usually did, and the obituary that was published in one of the newspapers in Paris was "The Merchant of Death is dead." Okay, and he was, I don't know, he was either shocked or amused. I don't know. It's hard to say what his reaction was, but based on that, perhaps the story is that he decided to give away his money, and in his will, he excluded most of his family, obvious, and divided the prizes should go who during the fall year before had conferred the greatest benefit to mankind, and with no consideration to nationality or but should be given based on simple qualification. They did not have to be either French or Swiss for that matter. And it was divided in equal parts, okay, of sciences. And for some reason, he excluded mathematics, and because either he wasn't too keen on math himself, or figured that there was already another rich Swiss mathematician who had independently wealthy. He was giving either had some started journals and was giving a type of award. Okay, but that's we're digressing. So I'll just continue with that. So that was his legacy, and then it took for a while for the Swedish academies to decide as to how to organize all of this. But eventually they came together and appointed various committees in different fields of experts, primarily from the Swedish Academy of Sciences, and they invited nominations from all over the various major European and American universities, and from recognized scholars in their field. And obviously there was a lot of tugging going on depending upon who was more powerful or who had more clout. And a Swedish chemist named Arrhenius, who was already well known and reputable chemist, he managed to control the nominations and selections for several years in the beginning. Okay, and now, what exactly? So it was an irony of fate, Nitroglycerin, on one hand, as a cardiologist, obviously, we handed it out like candy because, it expands your blood vessels and relieves the temporary uh, chest pain that can occur due to lack of blood supply. So the vasodilatory effect was well known from for several hundred years, so to speak. Okay, and at the same time, the same nitroglycerin can kill you with explosion. And the same now there's an interesting story that a vasodilator's effect is done due to a chemical called nitric oxide, which is chemically NO, which is unstable and relaxes the blood vessels. And the mechanism was elicited only fairly recently in 1986, type of thing, about 130 years after his invention. And nitric oxide is kind of a signaling molecule for cardiovascular system. Okay, so this was, so it took a while, to be recognized as effective. And the same way, while researching chemicals, a chemical was tested, which was the original sildenafil, a vasodilator, that expanded the blood vessels. But the side effect of that was that it caused erection in the males who were the test subject for phase 2 study. So that's why the company decided there was a lucrative market to be assigned, to be tapped, and that led to the floodgate of Viagra. Okay. Okay, and there was a very interesting movie made about him, about a Viagra salesman and his peccadillos with a patient. Okay. Now, here are some fun facts about the Nobel Prize, that the laureates have to submit the speech 24 hours before so that there's no mistake or faux pas. And then the medals, obviously they're very cherished, and displayed with pride. But 2 medals were sold, one of them by the enfant terrible of molecular medicine, James Watson, okay, who was the head of the Cold Spring Harbor Library, because his son had schizophrenia and he had some financial difficulties. He was born by one of the Russian billionaires, and he actually returned to Watson. Okay. Similarly, one of the Australians, he was traveling through a Fargo airport, after attending a meeting, and the medal was, alerted the bells from the secure airport security. So that's another story. And then a couple of Nazi scientists who were escaping the Nazi persecution, they were stuck in Copenhagen, and when Denmark was being invaded, they were worried that the Gestapo would confiscate these medals, so they decided to dissolve them in acid and left them in the laboratory of, I think, Niels Bohr type of thing, and they got away with it. Then finally they recrystallized them. Okay. And the condition for Nobel Prize is that it cannot be given posthumously. There was one exception. There was a scientist who was dying of pancreatic cancer named Ralph Steinman, and the Nobel Committee was not aware that he had passed away 3 days before. So that way, he was the only one who was actually given uh, the posthumous award. There's another story of a lesser-known name, obviously a lot of you know Marie Curie, who won the Nobel Prize twice. But there was more unassuming scientist who won 2 Nobel Prizes in physics, a guy named John Bardeen. His first prize was for transistors, and second one was for condensed matter physics. Okay, and when he went for the first time, the king of Sweden asked him, "Well, Dr. Bardeen, he did not bring his family," and obviously, I think he had to come up with an idea, and his response with the presence of mind that perhaps next time. And sure enough, a few decades later, he did win the second Nobel Prize, and he did take his family with him at that time. Okay, and again, that sometimes it can be a long wait. And Peyton Rouse, who had done the uh, original work on a Rouse sarcoma, a type of very malignant tumor in chickens that occurred back in 1905, and he received Nobel Prize almost more than 50 years afterwards, when finally the viral etiology of cancer was proven as to how changes can take place. So the trick is, if you're gunning for Nobel Prizes, then it's helped them live longer. Okay, and at the same time, there are some people who are lucky. There are two teams for of Chinese ancestry scientist Yam Yang and Mills Lee, who had done work on something very complicated on parity breaking in particle physics. Okay, and it's hard to explain. I'm not even going to try it. And that done was in 1956, and very next year they were awarded Nobel Prize. Okay, so it just, the gnomes in Sweden work in a more mysterious than God herself. Okay, now just for the face of records, Marie Curie is well known as one of the first women to get Nobel Prizes, and she won 2 Nobel Prizes. One was for radioactivity, and the second was for discovering 2 new elements, polonium and radium. Linus Pauling got a Nobel Prize for chemistry, and he's the father of so-called physical chemistry, as we'll talk about him when we talk about chemistry. The second was for peace. So he was strongly involved in a nuclear disarmament movement that started after Manhattan. Okay, Frederick Sanger, he's a very unassuming, low-key biochemist whose first Nobel Prize was for crystallography and determining structures of, I think it was for hemoglobin, to the best of my recollection. And the second one was for DNA analysis method, the Sanger method, that was now been replaced by more faster this thing. John Bardeen, we already talked about. Okay, Barry Sharpless, that he was a little less known to me. That this was the first prize was on some type of a chemical reaction, which I don't know half understand it, so I'm not going to get into it. Then he shared a prize with 2 other Nobel laureates for something what is known as click chemistry, which I have no idea what that's all about, and I'm not going to touch that for the time being, because that's above my pay scale, so to speak. Okay, a few more interesting facts. John Goodenough, he was the oldest Nobel laureates, who got the prize at like 97 or something, some ungodly age type of thing. So, and he lived to be, for lithium batteries. That was fairly recently, type thing. So, and he shared the prize with 2 other uh, uh, discoverers in 2019. On the other front, other than the joke prize, in my opinion, which is the so-called peace prize, which was given to the young Pakistani girl, who was suffered under the Afghan Taliban. Was that the scientist was a fellow named Mr. William Bragg, whose father was a Nobel laureate, and he shared the Nobel Prize uh, in 1915 at a young age of 25. And he and his father were the who is who of British chemistry for several decades, and mentored so many other Nobel laureates, you know, uh, under their under their supervision. Okay, and obviously this Nobel Prize is a pride for the countries, and obviously the United States leads the category, and a lot of them is due to expats and exiles from from Europe and Nazi Germany. Okay, and the second the category is the Brits, and with the start of industrial science, followed by the Germans, French, and then the list goes down. Okay, and obviously even the smaller countries have had their share, type of thing. And the newest country which has come to the forefront was just with the uh, uh, formation of Israel. They have managed to win, for us, a relatively small population, they managed to win 13 Nobel Prizes. India has her share. Yeah, the Japan had to wait for several decades to get, even though the Japanese were the first to westernize and get involved in research. A lot of times, they were kind of left off for either knowing or unknowing bias. And amongst the universities, there's no surprises, starting from Harvard to Cambridge and so on and so forth, the list goes down. One interesting thing that to be mentioned is that the Bronx High School for gifted, has had more than their share of Nobel laureates. Okay, Stanford before 2000 was a relatively small customer, but then afterwards, they've caught up with substantially. Okay, and then again, the universities counted as, even if they've had any association with the university, they count them as one of their Nobel laureates. So whether they got their bachelor's or their master's or their PhD, or that they were there only for a short time. So whatever way they want to increase their credibility, so to speak. And a couple of non-university laboratories have been well involved as well. The one that from this side of Atlantic would be the Bell Laboratories, which was a commercial commercial industrial independent laboratories that has had several Nobel laureates from their research team, because they were well-funded independent researchers in New Jersey. And on the other side, the Wellcome Trust is a charity organization which was done by a pharmacist in UK that works in collaboration with Cambridge. The Wellcome Trust has been a huge presence in winning Nobel Prizes. Again, this is not this rather busy slide illustrates as to how the Nazi Germany had contributed as to how many people have migrated from Germany and Russia, India, other countries, from the Netherlands, mostly from Germany. That's the largest contribution, and majority of them, no surprisingly, have ended up in the United States. You can see that as many as 34 from various countries have migrated to the US. And this data may still be a little out of date, but you can just see how the loss of one person and the political philosophy had a huge impact. And not only just Nobel winners, but again, in this 8 years that the Nazis were in power, I'm sorry, in the first 8 years, there were almost 7,500 academics, artists, physicists, biologists, type of thing. And even after the war, the pursuit of German talent continued. There was a secret operation that was instituted by CIA, perhaps, or OSA, the predecessor of that, was called Operation Paperclip, to grab all the German scientists, uh, disregarding whether they were involved in the Nazi Party or not, and bringing them to work for the US, including the pioneer of rocket wizardry, von Braun. And there's a hilarious lyric done by none other than Tom Lehrer, talking, praising about I don't care, the rockets go up, I don't care where they come down, about von Braun. Okay, so and the Russians had their share, and they captured a lot of the other scientists as well. So both sides had a mad dash for grabbing German talent. Okay, moving on to, and the varieties of categories, only, it goes, Nobel Prize selection goes based on fashions as to goes that. Say, back in the early days of 20th century, it was particle physics, later on by atomic physics. And there's difference between the two. Particle physics was primarily nuclear. Atomic physics was trying to see how to explored the split the atom, and the quantum science that was involved, and molecular biology with the discovery of gene, molecular chemistry and biochemistry have been very popular, semiconductors and optogenetics and photonics, where using photonic energy has been big into it. So medical imaging gets its share with the various devices, and obviously reproductive sciences. So you can just see that the gamut is, but the predominant ones have been particle physics, biology, atomic physics, and neuroscience. So those have been the big winners type of thing. And sometimes some of the highly cited papers go unnoticed as well. So only exception was a paper produced on a carbon form called graphene. There was only one scientific paper that was published, and that was good enough for Nobel Prizes, type of thing. So, okay. And so, depending upon how the articles of the majority of practice, we already talked about which domains are predominant. Okay, and so this was somebody had done a very scientific study as to which fields and how many their papers are quoted. Okay, and now again, the one special group of people need to be acknowledged in this thing, that the quote unquote chosen people, as to how we talked about this in the science of race class that most of you attended, that the Jewish people or Jewish diaspora have, being such a small number of the world population, have managed to win 20% of Nobel Prizes, and the causes are remain to be anybody's guess. Whether it's a genetic thing, or whether the tendency to emphasize on education, working in urban areas, or occupations that require a more intellectual ability. So again, so they've had a huge share in physiology, medicine, physics, chemistry, and so the numbers are, remarkably uh, dominance shows. So it's an exclusive club, as to you can just see how in the price maybe it merits the price if the work is rewarded by two or three other rewarded jointly. So okay, so this is how the prizes are divided, as to how many people got the out and out single prize versus it was shared by varieties of people. Okay, so this is how they managed to come up with the ideas, whether it's going to be a shared price or not. Okay, and there's an interesting book for those who are interested in the super achievers, about the remarkable Jewish contribution to, based on Nobel sciences. Okay, okay, and we already talked about the national pride type of thing, and sometimes the selection process is depends upon the pettiness in the committees type of thing. Okay, so okay, all right, and again, so there are, so we already talked about this part earlier. So now there are some glaring oversights that have taken place in sciences. For example, some of the names may not be familiar to you, but especially Nicholas Tesla is well known, because there is almost like a Tesla cult, that there's a lot of conspiracy theory as to Tesla was responsible for everything from sunlight to electricity to, to visiting aliens or what have you. And he was an eccentric man, obviously a genius par excellence, but unfortunately had a. And there was a movie made recently about Edison and Tesla called The Current Wars. So we'll talk about it if time permits. And at the same time, there was no prize for cosmology. So Edwin Hubble, in spite of his discovery of the which it changed the whole science of astronomy and cosmology, did not get. He obviously he nominated, and he was very anxious to win the prize, but somewhere along the line, he got overlooked. But then after him, a lot of the astronomers have received Nobel prizes, so he was just a little ahead of his time. The one couple of women, or three women, who have been snubbed was, well, I already talked about the Jocelyn Bell Burnell, who discovered pulsars, and that was she was a postdoc student and she was overlooked, even though her mentor, astronomer, had nothing directly to do with it, he got the award. Okay, similarly, when it comes to a lot of physics discovery, Madame Wu was equal participants in Cornell or Columbia. In earlier, we talked about the symmetry breaking theory, and she got overlooked. And George Lemaitre, and who had a lot to do with the expansion of universe, the so-called Big Bang theory. So he had proposed a lot of the ideas, which uh, proved Einstein wrong. And obviously, he had died before that, so perhaps one can say that there was a legitimate overlook. Another person who has done a lot of original work was a guy named George Sudarshan, who had done a lot of original work in quantum physics or quantum science. And there is actually a equation or form research that has been marketed as Sudarshan and the guy who actually won the Nobel Prize at the same time. Okay, so but he was overlooked for whatever reasons, type of thing. So this is just so there are a lot of weirdness that one can find. And at the same time, during the Nazi Germany, I know Hitler or the Nazi Germany had banned several of the Germans who were nominated and won from accepting the award, type of thing. So there were two or three people who were actually nominated and they did not get the award. At the same time, there are some glaring oversights, such as the vaccine developers. Neither Sabin or Salk got the Nobel Prize, and there was a lesser-known person named Maurice Hillman who worked for, I think, one of the pharmaceuticals, and he was instrumental in developing as many as 16 or 17 vaccines for a lot of the rare diseases such as encephalitis, meningitis, etc. And he was never recognized, by so people who contributed to a huge extent for saving humanity were overlooked. So it's a mixed bag as to how that goes about. And again, as we mentioned earlier, there is no prize for mathematics, but there is a prize for uh, mathematics, which is called the field medal, which is, again, it's just given only every 4 years because it's very hard to do original research in mathematics because a lot of the research that was already done back in 19th century by the giants of mathematics, such as Euler and Hilbert and Gauss, and so a lot of the work was already done at that time. So, but and now obviously it's a lot harder to do original research on mathematics type of thing. So, and and there was another equal prize that is given by King of Norway for under 40 research called Abel Prize, ABEL, that is given by the for with Norwegian by the Norwegian royalty type of thing. So, and and he instituted the prize when he learned that that the Nobel would not include mathematics as thing. So there is some recognition type of thing that is given. Okay. Okay. All right. Moving right along to the major category, or which is physics. Physics prizes have been awarded, as many as 117 times. To 225 people. We already mentioned John Bardeen. Okay. So and people have received, so preference was given in the beginning for experimental rather than theoretical. So it just depends upon because one of the reasons may be that because the Swedish committee of selection was dominated by chemists, including guys who may have heard about angstrom, we use the angstrom scale, and at the same time, that uh, and again, various nationalities were, favored. Sometimes, the Swedes tried to play both sides. That sometimes they favored the French, sometimes they favored the Germans. So they wanted to keep some type of a balance between the two type of things. So, okay, and there was a French scientist who has provided the proof for existence of atoms. Okay, and he was nominated several times, and it took a long time for the Swedes to accept him, and then finally in 1926, he was recognized and was given a nod to the Nobel Prize. So a lot of the personal biases of the committee had a huge influence on who gets selected and who does not. Okay, and now as early as we talked about, that Max Planck, who was one of the earlier German physicists, and he was the one who I mentioned earlier that he was told that there is nothing, but he continued and to work in mathematics. Now, as we talked about earlier, that the science of heat was a well-researched subject at that time, and with how any object or a metal object or a cylinder, which is perfectly black, when it is heated, it changes varieties of colors, and that color had to do with the wavelength of the light and the intensity of the radiation as to how high the temperature is and how the wavelength thing. So this was a big problem in terms of explaining the phenomenon as to how the heat is radiated out of a object as to how it's heated based on the classical theory of light as to in heat. If we consider light as a wave, the amount of radiation that was excluded was becoming exponential and did not make sense type of thing as to how to explain how the radiation was emitted, that type of thing. So based on simple thought processes alone, Planck came up with the concept that if the light was behaving and was released in various quanta, and depending upon the temperature, the frequency curve, the intensity of the radiation and the wavelength match perfectly. So this was the groundbreaking idea as to if the light was estimated as being released in various quanta, and depending upon the rise of temperature, he was able to make sense as to the curves of the intensity of radiation match perfectly with the wavelength. So this was and this was the revolutionary science as to how and he came up with various calculations of something called the Planck's constant as to the amount of energy that is being released per second. It's a pretty tiny value type of thing, but again, it became the amount of energy that is in a single particle of light, which later on came to be qualified as photon. Okay, and we'll talk more about it as we talk more about the particle physics concepts that evolved in the early part of 20th century. Okay, and again, then Planck was a giant in his own field as a leader of German physics. He lived to be 90 plus years old, had a lot of personal tragedies during the war, as well as losing his family members. And it was, again, as it happened in a lot of time in the Middle Europe people, he was a great musician, mathematician, and a force to be reckoned with. Okay, so and so that was the start of the earlier concept of quantum energy of photon. Okay, then moving on to the early part of 20th century, the most famous Nobel winner of all times, perhaps not just in physics, what has to be Albert Einstein, and this was in 1905 was considered his miraculous year, his annus mirabilis, type thing, and he produced a series of 4 papers, which we'll talk at length about it in next few slides. Okay, and just to summarize that the first paper proved the nature of light, that light behaves in a quantum manner or quanta of packets of energy, so to speak, of photons. There's a second paper, which was something called the Brownian motion, it just proved in plain exists that because even in the late 19th century, various respected scientists had doubt as to whether there actually was atoms were a figment of imagination, or there really was such a thing such as atoms or not. So there were a lot of schools of thought. So Einstein, based on his mathematical and pure analysis of something called the Brownian motion, proved that yes, atoms do exist. And the third one literally changed the world, which is his famous equation E equals mc squared. Okay, and again, for in spite of the groundbreaking research, he was made to wait for several years until finally his theory of was proven by none other than the British. Remember, at the end of the First World War, they were not exactly on a friendly terms. So, and and there were some people, some chemists on the Swedish committee who were strongly opposed to Einstein getting prizes for whatever personal this that had, and again, they would show that he had not done any lab work, and it was mostly theoretical basis. So a lot of time there was a speculation that this was so-called Jewish physics and a Bolshevik conspiracy type of thing. Okay, and again, the chemist named Alvar Gillestran had a strong influence on the committee, and they did not want to offend him, so the controversy continued for a while. And some other physicists who actually recommended him to show that, so they just decided to come as a compromise that instead of his general or special theory of relativity, which was still not quite proven, that he should be awarded for his less controversial effect, such as photoelectric effect, for which there were already some other winners who were ahead of him, type of thing. So, okay, and his papers were rather very sparse. Basically, there were no big footnotes, no citations. There was not that much mathematics, and it was purely power of thought that he had come up with all these ideas, type of thing. And now, when there's a little ideology as to why the letter C for light, okay, and that may have to do with Latin word for swiftness called celeritas, and because before that, the other people who had measured as a letter V as in Victor for a velocity of light. So why Einstein chose C, okay, instead of a letter V, that still remains to be somewhat of a guess. Okay, and so this is, like one could say, well, this is a cartoon that I had from some of my older slides. He thought about E, A, and B, and finally settled for letter C. Okay, because he was, the rumors were that he was not a very good student, So, and he did not, fancy. He just did enough math to get by for his purposes, type of thing. So, and there are some interesting theories that he relied on some of his more diligent mathematician friends, okay, to help him with his math work. And a German mathematician named Hilbert, on his own, when Einstein had showed him his work, he was almost close to cracking the theories himself, but Hilbert was gracious enough that he did not try to steal the credit. So these were the technical names for all the papers that, okay, and on the heuristic, means that was just a philosophical point of view concerning the production and transformation of light. On the movement of small particles, which has to do with something called Brownian motion that goes back to the about 50 or 60 years ago by a Scottish chemist named Brown, who was looking at the motion of pollen particles on water as to how they jiggle about, as to, and nobody could explain why that happened, but Einstein, based on the atomic theory, mathematically proved that it was the water molecules that were jostling, the molecules, and that's what one of that was the explanation for the motion on the electrodynamics of the moving bodies. And so these were the two ideas that led to the frame of reference motion and perception of light as to between the observer and the object in motion. So these were the four papers that were as things. Okay, so we'll talk a little bit more in details as much as I'll try to explain in plain English as much as I can. So photoelectric effects is when electrons are released when light hits the metal. So he put the idea that light consists of discrete packets, as that means the word which came into vogue was quanta, as opposed to the widely accepted theory of wave theory of light, which we talked about, presented by the slit experiment, which we talked about at the end of 19th century. So this advanced the wave-particle duality of quantum mechanics, or quantum physics, as it is more properly called. Okay, and it has a huge effect on all the sciences and our everyday life, because everything that we do, starting from the computers to uh, smartphones, and satellites, everything depends upon the photoelectric effect of the lights, the charge coupled cameras, okay, and so various sensors, they're all affected, with the so-called photoelectric effect is depend upon the light hitting the sensor. All the digital cameras depend upon it. X-ray photoelectric spectroscopy depends upon it. So it has a wide-ranging implications on the modern life. Now, the atoms were proposed as early as by the Greek philosopher Lucretius, that we talked about in other classes, because he had proposed that the world is made of atoms. Okay, but again, this was a theoretical construct, and it was proposed by the Brownian motion, the erratic motion of microscopic particles. They bounce into each other. So it proved the theory on a more realistic basis. The atomic bombardment constantly changes at different times the particles more on one side upwards the other. So that's one of the explains the random motion. Okay, so that was the finally had proposed, and this was experimentally proved by a French chemist in 1908. And yeah, so again, the idea that were theoretically proposed were confirmed in a practical basis, and he was awarded Nobel Prize in 1926. So again, the atomic science was coming into the forefront of science. Okay, the special theory of relativity, okay, the speed of the light is fixed, is unchanged no matter anywhere in the world, and not relative to the observer. So so the velocity is whether you are in a moving train or whether you're standing on a platform of the station. The light travels at the same speed of light, and that again changes the whole perspective. And that was the fundamental basis of this special theory of relativity. Okay, and as you travel faster and faster, so, now obviously it is impossible to achieve speed of light, but if one could theoretically imagine that the space, the length contracts and the time dilates, and when you really approach the speed of the light, time almost actually disappeared. So that just proposed the concept of space-time continuum. Okay, and again it depends upon, so and then again he proposed the so-called mass energy equivalent, which as the energy, it depends upon mass times the speed of light. So mass is a factor of the energy. Mass and energy are intricately related to each other. Okay, and that we'll talk more about as we talk about particle physics, type of thing. And the speed of light, obviously, it's enormous again. So this way, if you get travel faster and faster, the object gets heavier, and the time dilation takes place. So this is the fundamental basis of all the nuclear devices and reactors. So the length contracts, the time dilates, and the weight increases. Okay, and because no matter what, we cannot break the speed of light. Again, there is some question about it lately, but that's only happens in laboratories. Okay, type of thing. But we won't get too much into it. And the laws of physics remain same no matter what reference of time, whether you are going up on a rocket, or you're going down, or you're stationary at an object type of thing. So so that was some of the thought experiments that he carried out, and changed science as we know it. And now the very first Nobel Prize that was given was in 1901 to a guy named Röntgen. Okay, and he was again, that just happened. He was investigating something called cathode rays. Cathode rays were in a vacuum tube where the two electrodes, the negative and the positive, uh, are connected, and the visible light, so, and they were covered in a cardboard box, and he was trying to take an image on a fluorescent screen which was painted with a photosensitive material. Okay, and he noticed a green glow from the screen. Okay, and he realized that there were some invisible rays that were coming from the tube but passing through the cardboard to and he did not understand the exact nature of it, so that's why he called him X-rays. And this is the standard electromagnetic spectrum that let me zoom in on it. We can see that the visible light is relatively small because the one that we can visualize, type of thing is quite small. You can see the visible spectrum is a very narrow band that we can see the frequency that starts from the VIP or the violet uh, to red spectrum, based on their wavelength type of thing. And we talked about the blue earlier type of thing, which is the shortest length. Now, beyond that, as the wavelength of light increases, we get into the ultraviolet, okay, and X-rays and gamma rays, type of thing. And as the wavelengths, I'm sorry, as I misspoke, I think, as the wavelength increases, okay, type of thing, we get into the radio waves, which have a long wavelength, okay, and that's where we can transmit the sounds at great distances, okay. And similarly, the amount of energy that the gamma rays have pack a wallop, and that's why they can be quite dangerous and fatal. And similarly, X-rays can be dangerous also because even though they have a narrow wavelength, they have a huge, they pack a wall of an energy, so that's why you can damage living tissue very easily. At the same time, radio waves, travel for long distances. Okay, so this is, the so-called electromagnetic spectrum, and well-known type of thing. And then Röntgen took picture of the hand of his own wife, and this is her finger. This is the most famous, the first X-ray that was taken, and obviously she was scared out of her wits, type of thing. Okay, and very soon the discovery became very popular, and X-rays were very widely used in less than 5 years. Were spread all over the Western world, and including Japan, as to people started using it for diagnosing fractures and detecting foreign objects in the body, and even was used as a new craze for trying to see whether your shoes will properly fit or not, without realizing the potential danger to the tissue that could occur. Okay, all right, and now on the other hand, as it happens quite often in science, a lot of this discovery were accidental, and a scientist named Henri Becquerel in France, was studying radioactivity that comes from some of the metals. He was working with uranium salts, and he exposed it to sunlight and left it on photographic plate that the uranium absorbed sun's energy and then emitted it as X-ray. Okay, so and it so happened that and sometime in February in Paris was overcast, and he decided to develop the photographic plates anyway, and the images were strong and clear, proving that the uranium salts had emitted light without any external source. So this was that was the spurious or accidental finding of radioactivity. And subsequently, the two young scientists, Marie and Pierre Curie, decided to study the phenomenon in more details, and in terms that found out that the leftover ore from the uranium, was even more radioactive, and they thought that there should be some other element that needs to be discovered, and meticulously, they worked on the element in the basement of their lab, okay, with pitch blende, and working on tons of pitch blende. Okay, they were able to extract about 1 or 2 grams of radium, and that was a discovery. Was one of the most powerful radioactive substance. And subsequently, she discovered another element, which she named for her native country, Poland, which was polonium. And obviously, so this was a groundbreaking discovery by Marie and Pierre Curie. The Marie Curie had no, Pierre Curie had died from a horse carriage accident, and then subsequently she had an affair with another married scientist and got a lot of adverse publicity, as it was known to occur in those days. And even now, her books and notebooks and her lab equipment is still radioactive. So even after hundreds of years, the radioactivity is still, so when people were studying it, they have to use lead cover gloves type of thing. And she died at a relatively young age from leukemia, which was obviously the side effect from the work that she was involved with. Okay, and she and her daughters were very actively involved during the war in using X-ray equipment on the war front. Okay, so that was so those were the first so-called celebrity, and we already talked about all the three. So this side is just the same thing in a different manner. Okay, on the other side, the Brits had their share. Okay, that young scientist from New Zealand who was considered a colonial because but he was working in Manchester and was working when the uh, on the on the atomic theory of Dalton, and was working with cathode rays and had discovered, the atomic nucleus and given identity to the atoms. Okay, now prior to that, J.J. Thomson had already discovered, electrons. Okay, and and Rutherford, did a very simple, elegant experiment, which we'll talk about here. That this is how, the idea was that, you know, uh, radioactive source was used, lead covered, and the beam of alpha particles were, went through a slit, were hitting the gold foil, and where, some of them were going through on fluorescent screen, some of them managed to bounce back on other side. So his intuition or idea was to count for scintillations or radioactive flashes on the other side, and it has to be that the particles that were sent out, or the so-called small wavelength particles called alpha particles, which were basically helium nuclei, hit something in the middle of the nucleus and bounce back. So that's when he proposed that there has to be some heavier object, has to be in the middle. So that was the idea of that the atoms had what we now know as nucleus. So the idea that J.J. Thomson had proposed, that the structure of atom that he had originally proposed as a so-called plum pudding, and so that fell by the wayside, and the atom that we know it as the classical symbol of radioactivity that is there on all sorts of warning as on all nuclear hazard material, the nucleus in the center and with electrons revolving around, that we see as a symbol, the yellow symbol, that came to be proven. So he had assigned his associates, a guy named Marsden and Hans Geiger. Hans Geiger was German, and later on is associated with so-called Geiger counter. And so that was the finding of, but atomic physics became nuclear physics. So the concept of atom that goes back to the Greek thoughts of Thales and Lucretius, and carried on subsequently by Dalton, and later on by J.J. Thomson with the so-called plum pudding, become the nuclear physics, that the atom indeed had structure and was a center, was the heavy object that was called nucleus type thing. So and so now and later on, Rutherford moved to Manchester, from Manchester to McGill University in Canada, and then subsequently continued to work on a very productive basis with his assistant Saudi, and later on moving back to Cavendish Laboratory. He continued to work on almost doing further work on almost splitting the nitrogen element. Okay, all right, and so he first time he was actually be able to do so-called successful alchemy. Okay, so now again, he was a physicist par excellence, but still, for whatever reasons, there is a strange sense of humor that the Swedes have, that he received Nobel Prize for chemistry. Okay, for transmutation, so to speak. So again, and so okay, and all right. Okay, yeah. Later on, the work that was done by him was uh, based on alpha particles and splitting the nucleus of elements type of thing. So, okay, all right. Now, again, we'll talk a little bit of this. Is a very busy slide, and I just hope it would work properly. That atoms to Higgs. Okay, so this is a course in 2 slides on so-called particle physics. Now, again, you can just say that is this academic, but wait a minute, that it has a role to it, and so we'll talk more about it as we go along. Okay, everything, as we know, is made of atoms, basically. Okay, so you, I, the sky, the table, the chair, everything is made of atoms. The paper that we write on, okay, and and underneath the atom, as we know, that there is a nucleus, as we just talked about, and the nucleus is the center heavy part, and the electrons, which are not actually little dots, but we can imagine they are waves, but for practical purposes, we'll imagine as point particles, so to speak, because that's easy to understand, and they're quite small. Okay, they're 10 to the minus 10. So again, 10 multiplied by 9 zeros, and so this is, so they're so they're quite tiny. Okay, and now again, the nucleus, and they're not just like exactly revolving around. If they imagine me as a nucleus, and then the electron is about 12 miles away, so most of the atom is literally empty, so to speak. Okay, and now again, and so in the center of it is the are composed of 2 elements: a proton, which is a positive charge, and neutron, which has a no charge at all. Okay, so that is again, smaller than the atom itself. Okay, and then again, so there are even, it's like that. So what is underneath that? And protons are made something called quarks, which are only mostly visible in complex particle accelerators, where uh, uh, protons and electrons are moved at an extremely fast, almost near to light speed. That's the only time when they can be visualized. But they are the fundamental blocks of all the matter that is there. Okay, all right, and there are, the concept of quarks is hard to fathom, but there were the two basic quarks that were proposed, so-called up and down quark. That is uh, all the heavy elements are made of the so-called up and down quark. The proton is made of 2 up and 1 down quark. So they have 2/3 of a charge, 2/3 of a charge, and down quark as a negative charge. And so that combines it to be 1 charge, which is the positively charged proton, and the vice versa. The up charge and 2 down charges make up a neutron, so there is no electrical charge. So that's how all the world is composed of the 2 up and down quarks and electrons. So that's all the 3 factors that make up the entire world as we know it. Everything starting from, and this is good enough to explain the entire periodic table with all the 93 naturally occurring elements. When people went to the moon, they thought that they will have some different elements, but alas, that even the moon is made of same things. Okay, and so this is the so-called standard model, which is called leptons, which are all the particles. Okay, and this is electrons, and there are some other types of uh, there are smaller particles which are again, arise from the sun, and they're even smaller and just travel but do not react with anything. They almost, while you're standing, the neutrinos may pass right through you. And so there has been a huge effort done at underneath some deep mines in Japan as well as in Canada to search for neutrinos, because they just almost pass through everything. So to catch them under heavy water, that's a big research project there going on. We talked about quarks, and then there were some other quarks that were discovered, and there were some cute names that were given, something called the strange quark or the charged quark, and then there were some other ones that were discovered which were heavier element, and then the standard thing, which were called the top and the bottom quarks. Okay, so but these are all primarily discovered in the particle accelerator. So, and for practical purposes, if you could just remember, the electron up and down chart, that just it gives the structure of all the known universe. And now again, how is all these things kept together? Because that requires something called the force. So it requires something to stick with it. Otherwise, it will all go in a circle. They'll go all flying, okay, or the electrons will jump into it and it will become neutralized. So there are varieties of other particles which are the so-called force particles. And the most common one is something called gluon, which makes all the quarks stick together. Okay, and the light is made of force particles called photons, which travel at fast speed and are released when two of these quarks strike to each other. Okay, when the particles collide, they move into different direction by exchanging photons. So, okay, and then there are other forces which are so-called electromagnetic forces that are dependent upon something called the W and the Z boson. And last but not the least, the gravity has not been explained, and the particle that is hypothesized called gravitron. And now all these particles, they're very light, but they all have masses. And when they were measured in laboratory, they did not have masses. So that is why the concept in 1964 was proposed that there has to be a type of a field which gives mass to all these elements, and that was considered the Higgs field. And Higgs field was based upon Higgs boson, and so the search went on for almost 50 years for something called the Higgs boson. Okay, and finally in 2012 at the CERN laboratory, the Higgs boson weight was selected. Now again, the Higgs boson is even shorter lasting, of 10 to the minus 25 seconds. So it's a very short lasting field. But again, all this research is important because the CERN laboratory has had generated so many other benefits that all the particle science has the underlying foundation of all the things that we use, such as radio, TV, computers, global positioning system, medical imaging systems such as X-ray, CT scan, MRI, and some of the new technologies. That's like with the lunar mission, we have had a lot of other advances that have taken place. The same way, the CERN laboratory has come up with varieties of discovery, such as the spectroscopic X-ray imaging. Okay, and you can just see the X-ray is a standard black and white image, but the spectral X-ray imaging shows a very colored image, which is equally as much details as it is provided with MRI and computerized scanning with much lower radiation. So, and this is, again, and you can just see that the details that are seen are exquisite. So that is called spectroscopic X-ray imaging. So all this technology has arisen from the CERN laboratory. And at the same time, there is a role for this hard particle therapy. I'm sure a lot of you who have had some relative or even yourself had advanced cancer have heard of proton beam therapy, which is very expensive, but a very targeted way of treating hard to reach cancer, which is called proton beam. And this is, low, the energy is very concentrated and delivered precisely at penetrating at the site of the cancer without damaging the regular tissue. And again, the photon therapy is used for X-rays, okay, for some skin cancers type of thing. And in Europe, there is a various directed carbon hadron therapy is done for some more difficult to treat cancer that is not so much used in the United States. But so there are varieties of hadron, means heavy particles that are used for X-ray treatment for detected cancer. And that was one of the reasons why the particle accelerators were funded for research, as we'll talk about further. And so now this is more explanation as to mass is basically resistant to motion, because if you're moving through a thick viscous fluid, there is resistance and things get heavier to move, type of thing. And this is again the example that energy is related to the speed and mass. Okay, so this is two are related. So we needed a mechanism to explain how particles acquire mass. So that's how the field concept came into thought back in the 60s. Okay, and again, in the field is not mean a agricultural field, but this is a type of field, so-called magnetic field. So as to like how the effect of the magnet is all around. So that is the field, how is the force is exerted. Okay, and by interacting with this field, the particle's energy is transformed into mass. Okay, energy is equals to mass per motion, and that was the fundamental reason for the so-called Higgs field. And finally, after 50 years of expensive and laborious research, a group of almost 1,000 scientists managed to discover it. And that was the big discovery of 2012. And Peter Higgs, who had proposed this, along with some other scientists who had proposed, they were finally recognized with Nobel Prize, of Peter Higgs. And he was also the winner of the Copley Medal type earlier. Okay, and now again, now I continued the research that was done was the right, and determining the speed of light, because the practical experiments were done, was one of the first experiment that was done by Abraham Michelson. Okay, I think it was at University of Chicago. He was the first American to win the Nobel Prize, as early as, because originally amongst the 19th century scientists, it was thought that there was something called mysterious substance called ether, which had through which light propagated, and based on this, that he had proven that yes, that there was no such element, because based on various mirrors and a very elegant experiment that he carried out and measured the speed of light, was same with in vacuum as well as in air. So again disproved the that there is no such thing as ether. Okay, so the speed of light was measured in air, which was again close to 300,000 kilometers per second. At the same time, in vacuum also almost identical type of thing. So based on interference, so there was and so that was the so-called famous Michelson-Morley experiments, as to how they were precisely able to measure the speed of light as it reflected along the screen into different directions, type thing. And it says a personal interesting story that Michelson was a poor son of a Jewish immigrant from California, and again he did not have enough funds to go to college. So now in those days, the access to precedents was relatively straightforward for any American citizen. So when President Ulysses was out, Ulysses Grant won his walk, he appealed to him, and he gave him, obviously instructions or note to be admitted to Naval Academy. Okay, and that's how he managed to get his degree. And later on, he was helped by none other than Graham Bell, and ended up with a PhD at University of Chicago, I think, to the best of my recollection. And that was so even a negative findings was recognized, and the whole ideology of the 19th century was disproven. Okay. Now we talked about the father and son this thing, and this was the so-called British royalty as to William Henry and William Lawrence Bragg. Okay, and so they were the father and son duo who did the work on crystallography. X-ray crystallography was trying to take various compounds, make crystals out of it, and shining X-rays and doing precise measurement of the atomic structure. Okay, and and they explain not just the of the regular inorganic elements, but also explain the other various organic elements such as uh, hemoglobin and other chemicals. I don't have the details at the time. And that again opened up, and they mentored so many other scientists. Again, so this was the structure, the lattice structure of the sodium chloride that they determined as to how precisely the sodium and chloride molecules were arranged. And again, the more proteins were, the larger elements, and they were a lot more complicated to determine structures. Okay, and that structure was meticulously carried out by several women who went on to win Nobel Prizes. The most famous one was a lady, crystallographer par excellence, named Dorothy Hodgkin. She determined structures of various complex, rather large molecules such as vitamin B12, penicillin, and the structure of hemoglobin was determined by a German immigrant scientist named Max Boruse. Okay, and later on, the most famous crystallographers were Watson and Crick, who made the element. Okay, and now I'm going to change subject to the most recent discovery that has a lot to do with what Albert Einstein, this thing was called. He had predicted, based on his general theory of relativity, something called the gravitational wave, as to bending of ripples in space-time caused by some other energetic process that occurs in the universe. So he predicted that, based on his general theory of relativity, that when the objects are moving at almost near speed of light, they would disrupt the space-time, that the waves would occur in space-time, and they would propagate in different directions. And so these cosmic ripples would travel at the speed of light, and it would give us the idea as to how they originate. So these ideas were proposed, and finally the experiment was suggested back in 1964, what's called interferometer, at two arms were devised at great distances to detect the gravitational waves, which would occur in space billions of years ago. And the proof was earlier proposed, and finally the experiments were set after huge expense. I think it was one arm was in Louisiana, and there was in Washington State, type of thing. So this was with two separate experiments that were carried out, I think. And the colliding black holes were finally proven in 2015. So there was a groundbreaking discovery of that. This was the groundbreaking image of two black holes colliding 1.3 billion light years away. And so there was the LIGO experiment. There was a laser interferometer gravitational waves. That was the abbreviation for LIGO. And that was given the Nobel Prize for that. And again, so we'll see the irony of it, that the people who had proposed this idea, Kip Thorne, and who is well known to moviegoers because he was involved in the making of the movie Interstellar. And this is how, let me see if I can get the details of his experiment. So this was the gigantic interferometer. Okay, the laser light is sent along this to measure the change in the length of two arms. Okay, you can see that the beam is split, right? So this is it sends out on two identical beams and long arms. Okay, light waves bounce and return. Okay, and the gravitational wave affects the interferometer slightly differently. Okay, the one is slightly extends, another contracts. So the precision is remarkably accurate. It has to be accurate, type of thing. Okay, and so the beam splitter and the light detector, this are arranged in number 5 here. Okay, so when the black holes collided, it just changed ever so minutely this complex, and they had to make sure that the vibration was totally isolated. So it was, and so it was a gigantic experiment. It involved 1,200 people, and the strange part was that only 3 people were selected for Nobel Prizes. So that just shows this to how out of date the structure of Nobel laureates have become. I think. Okay, so enough criticizing that. And so moving on to the other Nobel winners of, we'll just pick some that be of interest type of thing. Okay. And the guys, everybody knows who discovered radio was a guy named, or who was recognized as the founder of radio was a guy named Guglielmo Marconi, and a German scientist named Carl Ferdinand Braun. Okay, the Braun radios are well known, in the early days of radio type of thing. But the work was based on a lot of other people who had done work, and in fact, Marconi actually had not invented anything himself, but he was a great learner and had managed to read the papers of the other people. And a lesser known scientist named Jagdish Chandra Bose, who had done some of the, had done, turned out to be a component for wireless telegraphy, which preceded Marconi's experiment by as much as 20 months. Okay. But he, again, in those days, they were trained by the Brits. So the gentleman did not patent their inventions. And so he was disgusted with the thrust for making money out of it, and went back to Calcutta and became the professor there type thing. Okay. And but Marconi went to the idea that he packaged the Hertzian waves as well as Bose's something called a coherer, okay, which is a component for wireless telegraphy, okay, and put them all in a nicely box and patented that, with the British authorities, and went to the people who had the money and who were interested in, okay, in this type of technology. And there is the British Post Office, and was able to convince the uh, uh, postal authorities and administrators to give him funding, and even their engineers help him improve his equipment. Okay, so that was a Carol marketing genius, and now he's recognized as the founder. So that's a lesser known stories. And even some of the people who were on the committees, or in the patent office realized that, well, he actually has not, he's a fraud and hasn't actually discovered anything to per se. Okay. and 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 so these are some of the things that now Bose's work is being recognized by. So you can see there are some of the recent blogs that have been written about Bose's less recognized work. Okay, moving back to Einstein, and here's this thing that Einstein's theories were proposed as to how the change in the orbit of Mercury had to be, had proposed as to how, you know the is the general theory of relativity, would cause this slight shift in the orbit. Okay, and so there was a mission. These papers were originally in German, and they were sent to the British uh, astronomer, who was the powerful astronomer in Cambridge and a pacifist. So he was not involved directly in war, named Sir Arthur Eddington. And so after learning his paper, they had come up with an experiment to observe during the eclipse about the orbit and take pictures about the shift in the how many arc difference would take place in the orbit type of thing. Okay, so the first account for the general theory of relativity appeared only, in 1918. Okay, and so the British government had given funding of about £1,000 to travel to uh, Principe Island and Sobral Island in Brazil, to see, to see determine the orbit of Mercury during the eclipse. Okay, because that was going to be the most visible. So two missions were mounted, and Eddington, along with another fellow astronomer, went to Principe Island. Okay, and during, depending upon the weather conditions, managed to take big glass photographs of the sun and the eclipse and the transit of Mercury, and as to how much shift was there according to what Einstein's formulas had predicted. Okay, so, and again, and in Brazil the weather was bad, but in the Principe Island, that they were able to get a few correct pictures and make the measurements. And so, and that again, finally, the news traveled all around the world. And then again, okay, and the men of science agog over the results of the eclipse that was observed. Einstein theory triumphs. Stars are not, so this was the headline in the New York Times, stars were not where they seemed to be or were calculated to be. Okay. And so this was, the elaborate equipment that was devised by Sir Arthur Eddington, and you can see how the gigantic the telescopes were, and how elaborate it was to transport the equipment during the war to the small island and set it up and take big, X-ray plates and take photographs and develop. And as you can see during the eclipse, they were able to see the transit. Okay. And was a shift in the star positions was confirmed, the theory of bending of light, okay, that he had proposed. Okay. So that was, one can say that the Newtonian physics had been replaced by the Einsteinian universe. Okay. And again, the politics was strongly involved because Einstein being Jewish, by this time the Nazi Germany was rising to power, and the various German scientists had written letters in the two-part strategies that, well, this was repugnant to the Aryan sensibility. The result had been plagiarized from earlier Aryan research. So there was, the criticism from the whose work Leonard, who had done the work on actually on the theory of relativity earlier. And again, so they were becoming strongly anti-Semitic. Okay, the force that was introduced by the Aryan scientists like Newton and Galileo. Okay, I mean, that's the criticism is just totally off the wall and repulsive. Okay, and with that Newtonian gravity light, the bending of the light. Okay, so so this, so it just goes to show how politics interfere with it. Okay. And these are some of the Einstein's thoughts, as because he had almost, had expressed a strong, not atheist, but agnostic belief type of thing. It's nothing but the expression of product of human weakness. Okay, so this was so-called Einstein's God letter that was sold for $2 million. Okay, why? And that is, your guess is as good as mine. Okay. And again, he was, obviously, as philosopher, as Nobel laureates do, is they have comments and opinion on just about everything. And so these are some of his statements. And again, he had a strange sense of humor that this was when he was, it did not want to be taken celebration. So this was his photograph. So this is how he managed to turn off the paparazzi type of thing. Okay, and this is one of the famous pictures that appears on varieties of objects, of his admiration. And again, it's like and again, yeah, one has to give credit to his good sense of humor. That remark that if relatives prove right, Germans will call me German, Swiss will call me Swiss, French will call me a great scientist. If it is wrong, French will call me Swiss, Swiss will call me German, the Germans will call me a Jew. So he knew that, obviously a lot depended upon the scientific proof, but luckily for him and for the world, it turned out to be all right. And again, now, based on his theory, because he had his he did not believe that, he was not aware of the work that Hubble was and was working on. And again, to in his, he had an error in his calculation, and to make his calculation work, he had introduced a function called the cosmological constant. We realized that it, that his own theory, it suggested that the universe was dynamic, means was either expanding or contracting. So then he introduced what we can mathematics simply call a fudge factor to make sure that the universe was static. And at the same time, there were people who are more diligent mathematicians. A lesser known person, a Jesuit physicist named George Lemaitre. Okay, he had shown that the Einstein was not correct, and that the universe was expanding. And similarly, from Russia, a mathematician, physicist named Friedman, who died during the war, okay, had written letters that Einstein's math was not quite what it should be, and that the universe was expanding. Einstein was initially irritated and ignored Friedman's letter, but after he wrote him for the second or third time, he grudgingly admitted that Friedman was correct, and that the expanding universe made more sense, type of thing. And again, it took until almost 70 years for the American scientists Perlmutter and Brian Schmidt, the Australian we talked about, that they were astronomers, they were observing distant supernova and showed this, and that the universe was indeed expanding and at a faster and faster rate that required something called a positive cosmological constant, and their work was recognized by Nobel Prize in 2011. Saul Perlmutter. And now this has to be, there was a Belgian industrialist who had sponsored varieties of conferences for science. And starting from 1911, I think, they were called the Solvay Conference. And this was the fifth Solvay Conference. And that was the most controversial and the most famous, this thing. And this is a color photograph of this. And you can see that the number of Nobel laureates who are in part of the picture, and the only sole woman is Marie Curie, right in the front. But the other names are known to the students of physics, okay, and especially from Einstein to Hertz and Perrin, who proved Einstein's theory, Compton, who showed the Compton effect, okay, and de Broglie, who was again one of the pioneers of quantum science. Okay, so this was the Solvay conference where the controversy, and again in the back row, the future Nobel laureates, Schrödinger is there, okay, and so it's Heisenberg is in this picture as well, and Wolfgang Pauli, who went on to win the Nobel Prize, is right there too, okay. So it was a who is who of the young as well as the so-called old guard in the front, and this is Lawrence, I think. No, I think Max Planck, and this is Lawrence. Okay, so there are the varieties of who is who of the 20th century science were together in this picture. So it gets to be one of the most famous photographs, and this is that time the argument continued between Niels Bohr and Einstein about about the accuracy of quantum physics, type of thing. So that just, and now finally the arguments ended up in favor of so-called Copenhagen interpretation. On the other hand, the astronomy was, the big giant telescope was introduced at Mount Wilson in California. And earlier, one of the scientists from Indiana named Westo Slipher was working on measuring nebulae, and he was the first one who spotted something called the redshift. Along with that, these were called earlier, what they called computers, the women who actually interpreted the data that was generated from the stars. And so they were called the human computers. And one of the par excellence was a lady named Henrietta Leavitt. And they were measuring the shifting of the stars. And then subsequently, Hubble, who was kind of a was a man for all seasons. He was a good athlete, good mathematician, had worked in Cambridge, and was later on, worked as a teacher, and then went back to astronomy, and was stationed at Mount Wilson Laboratory, and was this is Hubble looking through the giant telescopes at Mount Wilson, and and this was one of the earliest findings, was that the galaxies were moving away from us, and again, they discovered something called the Cepheid variable stars to measure the distances between, they changed their brightness, okay, and it was related to the based in the change in the position, they discovered something called this Cepheid variables, and based on Andromeda galaxies were much further away than those in Milky Ways. So this this contrast in their luminescence led them to know that the Andromeda Galaxy nebula was a galaxy in its own right. And so this was, this founding of the so-called the universe was a lot bigger than was originally thought to be, that everything was not confined to Milky Way and it was expanding. So that changed on something called the red shift, meant that the galaxies that were further away had showed something called the red shift. And so that changed the concept of cosmology. And so the science became from astronomy to cosmology. Okay. and and again now at the same time, that the thoughts were given on something called the black holes that were proposed theoretically. Okay. And as you know, Oppenheimer was, before he was involved in the Manhattan Project, he was an astronomer and mathematician at that same time. So he had written theoretical papers proving that mathematically the black holes should exist, where the and varieties of mathematical methods, they had managed to calculate something called the black body radiation, and and how the certain different types of stars would behave. And some of the stars that were bigger than 1.4 mass of the star would collapse as they get older, type of thing, and it would collapse into nothing, not even light could escape this, and would lead to the formation of something of black holes. So that was theoretical concept that was worked out based on astronomy. And and so varieties of mathematicus, which was called the not just statistics, but something called quantum statistics, that was used by astronomer Chandrasekhar and as well as by Oppenheimer to calculate the presence of black body that theoretically they should exist. And it took for several years for it to be. Now, when Chandrasekhar had proposed the idea of black holes, this idea was poo-pooed by Eddington. Okay, and even though Chandrasekhar was a young astronomer, while Eddington was a well-established astronomer in England, and and again, even though most of the people who were at the conference agreed with Chandrasekhar's observation, none of them managed to speak up. Perhaps either due to bias about a young Indian scientist, or due to the fear of contradicting Eddington. And this about several years ago, there was a nice book that was written about the Empire of the Stars, about the obsession, friendship, and the betrayal in the quest of black holes. So this was a book written by, I think, a science writer. I don't think he was a scientist, about the Empire of the Stars, about the controversy. And then finally, Chandrasekhar decided that he had enough of working in Cambridge and settled at the Yerkes Laboratory in that is near Madison, Wisconsin. Okay, and he continued to teach at University of Chicago, and was recognized as a par excellence teacher, and worked during Second World War and in Maryland as well. And this was again, this so there was a lot of controversy about going on at that time. So, okay, I think we're moving right along, type of thing. And again, now this was another paper that a young scientist named Bose had written a letter based on something called statistical mechanics to Einstein, proposing the idea of subatomic particles when cooled to absolute zero would create something called a new matter, which is called the Bose-Einstein condensate. Okay, so this was a new state of matter that was proposed. Okay, let's see. You can see, and we all know solid, liquid, gases, and plasma, which is in the sun, ionized radiation. And this is something called, when it is cooled to a markedly low temperature, it forms something called the Bose-Einstein condensate. And finally, it was produced in the laboratory by using as rubidium, a metal, by two scientists in Colorado. Okay. Okay, I think we still have some time, so we can continue with for a little while longer. Okay, moving on to the founder of uh, quantum physics, because as we talked about, that the ability of light, and Niels Bohr was a Danish scientist who worked in Cambridge, and again had to explain the atomic structure, and it was hard to explain the atomic structure at that time, and so he had proposed the idea of electrons maintaining orbits and based on valency, to how to combine chemistry and physics was undertaken by Niels Bohr. Okay, and Niels Bohr had proposed that something called the atomic orbits, that electrons, where once the orbit is full, then the electron jumps to the other orbit, type of thing, and they had a certain quanta of energy, and varieties of orbits that were proposed by him, something called okay, and the concept came about as whether the electron was a particle or a wave, and so the ideology and the conflict between Albert Einstein and Bohr just continued. Okay, and and subsequently, Bohr was went back to Denmark, and the Denmark businessman had established something called the Bohr Institute, and subsequently he was instrumental as an equally powerful research institution comparable to Cavendish Laboratory was established at the so-called Bohr Institute in Denmark, and they had managed to help a lot of the Jewish scientists uh, who were escaping Nazi Germany. So this was, the birth of atomic. He had proposed a new energy, about the energy levels of electrons in the whole formula as to how the electrons behave around the nucleus, and so, and then again he continued to work along with in atomic physics, and afterwards, when he became aware that the German had succeeded in perfecting atomic fission, okay, and he had traveled to the United States and was instrumental in encouraging the American scientists and and in undertaking the atomic science project, and along with that, several other people who were aware of the potential for release of energy by nuclear fission, and that prompted Einstein and various other atomic physicists to write a letter to FDR to give funding and for atomic research and for the Manhattan Project. Okay, and after the atom bomb was tested, Bohr, along with some other concerned scientists, was concerned about the potential for death to humanity, and had managed to talk to Truman as well as Winston Churchill to put the atomic energy under United Nations control. But the politicians, being what they are, did not give him you know, any attention, and that led to the continuation of the atomic race. Okay, and so this was one of the ideas as to he proposed the concept of something called the orbital shells, as to how only once the orbit around uh, the orbit is filled up with the round amount of electrons, then the atom jumps to another orbit, and proposed the varieties of orbits as to how the orbital shells. It explains the atomic weight of various elements. Take, for example, barium. The orbit starts from 2, 8, 18, 18, 8, and 2. And that explains the amount of valence the element that is there. And similarly for radium, as you can see how the orbit gets full, and so they're chemically similar, and that explains the periodic table and unites it with their atomic weight. And so this was, and by this time, obviously there were other concepts that were proposed by Wolfgang Pauli, and as to how the orbits, can be occupied. That thing, something called the Pauli exclusion principle, and so once the orbit is full, it becomes inert and it moves on to the next orbit. That was the idea of shells of the electrons rotating in terms of around the nucleus, and so that was the idea of uniting chemistry with physics. Okay. I think I'm going to skip this for the sake of time, type of thing. Now, at the same time, there was huge attempts were done to correlate Einstein's general theory of relativity with quantum physics, and a man who was the pure mathematician who looked at the idea of beauty in mathematical equations, that he worked on it simply with the power of his mind on uniting these two philosophical concepts of general relativity and quantum physics. Okay, so he's describing, the unifying the but when describing electrons at high speed. Okay, and and he worked on it, as to seeing, and he was devised a formula as to the wave function and varieties of complex mass and a wave function, combining the two, reconciling the two separate independent theories. And not only that, he was surprised with his own result, that he came up with two different outcomes, more than he expected. Okay, and I noticed that day that there was also a mirror image particle that was with reverse properties that he came up with, which was so-called, which had the same mass but with opposite charges. Okay, and so this was, so a puzzling conclusion from his mathematical thought processes that came about, and so this was totally a surprise to him, a type of thing. So it was just like saying that you have your own doppelganger. Okay, and now to the surprise, a few years later, this was proven that not just electron, but with the same mass, but with a positive charge, that was proven in based on laboratory experiment by an American scientist named Carl Anderson, who was studying cosmic rays in a cloud chamber. And cloud chamber is nothing but basically water vapor with magnet. Okay, so it shows as to how it reacted. It traveled in a totally different direction. So it had a positive charge. So something that was unexpected based on so-called Dirac formula. I'm not even going to try to explain this as to how, this is very complex math type of thing. But this formula was, is on his grave at Westminster Abbey, okay, in 1902, Paul Dirac equation. And again, now the varieties of physicists were involved, but I think for sake of time, we are not going to get into it. And and that just gets to be very abstract physics, and I don't think most of you would care for it at this stage, unless you are a physicist by, type of thing. So again, so varieties of people, and now Heisenberg had a role to play because he was a national German, and people were afraid that he was going to be the so-called founder and a mover of the German nuclear weapon. And there were attempts carried out by the secret services to assassinate him. And I think I talked about it in the class on atomic class that we talked about, and that there was a scientist, come baseball player, who was sent to kill Heisenberg, and when he was going to be attending a conference. So there is some interesting clock and dagger stories that are part of the atomic history. Okay, but again, I don't want to digress too much. Okay, all right. So no, but fortunately or unfortunately, their attempts never actually panned out, and there are some interesting findings on that. But again, that's not part what we're here to talk about. Okay, now after discovery of nucleus in 1911 and splitting of the nitrogen by Rutherford, not much happened in nuclear physics until 1912. Okay, that one of his students, Rutherford students, who was happened to be in Germany during the First World War and just happened to be in the wrong place and ended up spending 4 years in prison of war camp. And finally, even at that time, he managed to continue doing experiments by bribing some guards for radioactive toothpaste, believe it or not, that was marketed in Germany. And so they were doing simple experiments with simple tin foil and bending an electroscope even while in prison. Now at the same time, Juliet and Curie, Marie Curie's daughter, were well-respected researchers and who are doing radiation research with with electron beams and radioactive sources. But it turns out that they had misinterpreted the result that in the laboratory and had published a paper in a hurry. Okay, and finally, when Chadwick and Rutherford read these experiments, they realized the curious mistake, and so they repeated some of their experiments and type of thing that and they thought that the explanation that Curie had provided uh, that that the gamma photons were causing the radiation, but Chadwick clearly thought that photons did not have any mass, and he repeated the experiment. The radiation that was emitted by beryllium, which was right in the middle from a polonium source, okay, was due to a different uh, object that was there, which was, the which was totally a different particle that Rutherford had hypothesized but had not proven. And that was the neutron, which had no charge at all. And so so that was the discovery of neutron in 1932. And so in other words, the Curie's experiment details were correct, but their interpretation left a lot to be desired. So Chadwick determined that the mass of the new particle was more than that of a proton, but did not have any charge. So that was the discovery of neutrons. So the whole puzzle was coming together based on this thing. Okay, now this again gets down to the most interesting part of the when when nuclear physics, when atomic physics became nuclear physics, so to speak, or was the science where that the German chemist Otto Hahn had done experiments, by at that time, and but he was not a physicist by training, and it misinterpreted the results, and his co-worker named Lisa Meitner, he had sent a copy of the paper to her, and then she and her nephew, who was also a physicist named Otto Frisch, they were exiled in Denmark at that time, and they saw the results that Otto Hahn had achieved, but was unable to interpret as to how targeting nucleus with neutron. Okay, he managed to. Let's just see. Okay, I'm sorry, let's go back to, okay, it was targeted and had was bombarding uranium and had managed to discover barium. And so he had realized that they had managed to split the uranium nucleus into barium and krypton. Okay, so those are the two different elements. Okay, and so that had taken place. So they had managed to split the nucleus, but had not interpreted the results correctly as to how it was bombarded, and there was a fission product, and the neutrons were released. And this was, this is, so they finally interpreted the results correctly and published the results, because up at that time, there was no secrecy code that was imposed. So the articles where the science was still, more widely shared, and there was no, blackout that was proposed at this time. So this was the day in science history, 1939. And that just rang the bells through all the powers in Germany as well as Britain and United States. Okay, and this led to the funding of Manhattan Project and the cost of billions of dollars, and with about thousands of scientists, and the project was undertaken on a massive scale, and that you saw in the movie Oppenheimer. Okay, and the final words that Oppenheimer, who was a theoretical physicist and was the head of the atomic project, and his words were, he describes the word from the Hindu religious epic Bhagavad Gita. Okay, and this part or this is the actual original words in Sanskrit type of thing, but they were paraphrased more or less to I have become dead. And I will not try to pronounce this, but I think I still know my high school Sanskrit enough to know that what the meaning is, but it's not a literal translation of this stanza or part of the Gita, where uh, as it just translates more or less to similarly. Time, word destruction causing powerful, here come without excluding anybody. So it's just in the translation is awkward, but it gives a more or less a similar meaning. Okay, so this was Lisa Meitner, that she had a role in nuclear fission. She was nominated several times in different disciplines, but somewhere along the line, she was never acknowledged. So just goes to show how the politics, and and later on, so she saw that the element 92 was split into two, 56 plus 32, so barium plus krypton. Okay, and and then subsequently she had also discovered a radioactive element, protoactinium, with an atomic number of 91. Okay, and again she was she was not interested in working on the nuclear fission. So in spite of being invited, she didn't. She was a humanist to the core type of thing, and and she's been recognized as element 109, is labeled mitronarium. Okay, and she continued to work in Germany and do research. Okay, and I think this is a post-war era that we're coming up to. So I think I've recorded up to nearly 2 hours worth. So I think we'll stop here, and we're moving reasonably on time, and we'll continue next time. Okay, thank you, folks. Well, I'll see you next week.